The thing about magnet motors is that it's very difficult once something is inside of a magnetic field to get it outside of the magnetic field without using any external energy. So I'm going to demonstrate an example of that actually happening, getting outside of that magnetic field. So here I have an array of magnets. They all oriented in space similarly. Same size magnets. So if it's north-south, it's north-south, north-south, so on, all the way down to the very end. So you start off with north on this side, end up with south on this side. The bottom piece of metal is just to hold these in place, hold the magnets in place. The top piece of metal is a little bit more important. It combines the flux, or it connects the flux between adjacent magnets. So the south side would have magnetic flux going to the metal to the north side. What that does is that it softens the flux that it occurs above this metal, and that's going to play out in a minute. What I have here is a wheel and axle made up of a 1/4-inch metal rod, iron rod, and 2 sandwiched 1-inch ring magnets with a 1/4-inch hole, and those each are holding a piece of acrylic. Now I'm going to add a magnet to the other side. So these are the pieces separated: the 1-inch magnet, acrylic, and the other magnet. So I want these in repulsion. Let's see. Yep, that's repulsion. So let me try and get this on here with one hand. See how lucky I am today. There we go. Yep. So that's in repulsion. Let's add the acrylic. There we go. And let's add the other magnet. That's an attraction. Perfect. If I can get it on. There we go. So now I'm going to take this wheel and roll it over this array. So the inside of these magnets, because they're in repulsion, they have a very strong they have a very strong field here. So if this were north, then that would mean, or if this side were north, that would mean this is north. Or if this side were south, that means this is in south, because they are in repulsion. So it's pushing away. But once you get past that mark, this is what happens. And there you see it broke past the sticky point. So it got to a velocity that, an exit velocity that takes it past that last magnet in the array. And just to show that it's relatively even, I'm going to turn this around and make it go the other way. This piece right here is just to keep this magnet from popping up and attracting the magnet, the wheel. So here we go again, other direction. So I'm going to hold it and let go. Got some interference. There we go. Now this array, the second array, is, actually, before I get to that second array, so what's important about this is, one, that exit velocity, and two is that I think this may actually be acting as one big magnet with one pole on this side and the other pole on the other side, but I'm not sure. So if you wrap it around, then you don't have a north and south on, a big north and big south on either side, but I haven't confirmed that. Now, what happens when you don't have exit velocity is this. So these are smaller magnets here, but same arrangement, metal on the bottom, metal on the top. I'm going to start this here. Oh, okay, whoops, I got exit velocity. Let's try it again. Oh, there we go. All right, well, I thought I had that one too weak. Let's try going in the other direction, see what happens. There we go. That time, not enough exit velocity. So then it just bounces back. So that's the example when you don't have enough exit velocity. Again, these are weaker magnets on the bottom, but these magnets are pretty strong up at the top, or on the wheel. So now let's try it on this last configuration, where we'll have a set of 4 ring magnets connecting bolts together. Again, same orientation, north-south, 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 north on one side, south on the other side, or vice versa. I'm not exactly sure. And what this does is that it pulls it through in different pulses, but it still reaches exit velocity. Not that time. Well, let's try it again. There we go. There, so we reached exit velocity again. So, the other thing about this first array is that I can start this somewhere in between, so it doesn't have to start from the very end, and it'll still get exit velocity. There, it keeps running into that little thing in the middle. Try it one more time. Yeah, it keeps running into it. Oh, that's because I'm not doing it straight. But the point is that this thing can reach exit velocity on this magnetic array, which means it's going fast enough to be able to do additional work after it gets past the magnets. So if you have another magnetic array, you can keep it going. Theoretically, you could go perpetually, but I'm going to keep playing around with that and see where it takes me. All right, that's about it. Thanks.